In the pantheon of global comfort food, the pizza stands alone as the undisputed king. It is a dish that transcends culture, language, and borders, evolving from a peasant dish in Naples to a multi-billion-dollar global industry. In the United States alone, 3 billion pizzas are sold every year. But we are not talking about the artisan pizzeria with a wood-fired oven on the corner. We are talking about the industrial miracle of the frozen pizza. To feed a nation of 330 million people, you cannot rely on hand-tossed dough and individual attention. You need a factory that operates with the precision of a microprocessor and the scale of a steel mill. Welcome inside a frozen pizza megafactory, a facility capable of churning out 1.5 million finished pizzas every single day. This is a cathedral of carbohydrates, a place where biology, chemistry, and heavy engineering collide to create the perfect circle. The journey begins outside the factory walls, in the towering rows of stainless steel silos that dominate the skyline. These silos are the lungs of the factory. They hold hundreds of tons of wheat flour. But this is not just any flour. It is high-gluten, hard red winter wheat. The protein content is strictly controlled at around 12% to 14%. Why? Because protein equals structure. In the world of industrial baking, consistency is the holy grail. If the protein content varies by even 1%, the dough might be too sticky to machine or too tough to chew. The flour is moved from the silos to the mixing room not by conveyor belts, but by air. A pneumatic transport system blows the flour through tubes at high velocity, aerating it and ensuring there are no clumps. It arrives in the weighing hoppers above the mixers. Here it meets the second most critical ingredient, water. But in a factory of this speed, water is a variable that must be controlled. The friction generated by the massive mixing blades is so intense that it can actually cook the dough before it leaves the bowl. To counteract this friction heat, the water is chilled to a precise 34 degrees Fahrenheit, 1 degree Celsius, just above freezing. This icy water keeps the dough temperature in the safe zone, preventing the yeast from activating too early. Now we introduce the biological engine, yeast. The factory uses a specialized strain of Saccharomyces cerevisiae, commonly known as baker's yeast. This microscopic fungus has one job: to eat sugar and burp out carbon dioxide gas. In a home kitchen, you might use a teaspoon. Here, they use buckets of liquid yeast cream, pumped directly into the mixer. Along with salt to tighten the gluten network, sugar, food for the yeast, and soybean oil for tenderness, the ingredients are dropped into a horizontal bar mixer. This machine is a beast, capable of handling 2,000 pounds of dough in a single batch. As the giant steel arms rotate, a violent yet beautiful chemical reaction occurs on the molecular level. The two main proteins in the wheat flour, gliadin and glutenin, begin to uncoil and entangle with each other. Water acts as the solvent that allows them to move. As they link up, they form a complex, stretchy, elastic web known as the gluten matrix. This matrix is the skeleton of the pizza. It is what allows the dough to stretch without breaking, and crucially, what traps the bubbles of carbon dioxide gas released by the yeast. Without a well-developed gluten matrix, you don't get a crust, you get a dense, hard cracker. Once the mixer timer hits 0, The dough is dumped. A 2,000-pound blob of living, breathing dough falls into a giant, pale organism. It is immediately transported to the chunker. This machine uses a guillotine blade to chop the massive blob into manageable 50-pound chunks, which are lifted by a vertical conveyor to the hopper of the sheeting line. In a traditional pizzeria, a chef tosses the dough in the air to stretch it using centrifugal force. This is gentle. In a factory, we must be careful not to crush the life out of the dough. If we used high-pressure rollers immediately, we would pop all the microscopic gas bubbles, ruining the texture. Instead, the factory uses stress-free satellite head rollers. Imagine a large rolling pin surrounded by dozens of smaller, free-spinning rolling pins. As this device moves over the bed of dough, it gently massages it outwards, reducing the thickness gradually. It creates a continuous river of dough, 3 feet wide and endless, moving at a speed of 50 feet per minute. But the dough is stressed. The gluten strands are tight like rubber bands. If we cut it now, it would shrink back into a smaller shape. The dough needs to relax. It enters the proofing tunnel. This is a long, warm, humid chamber. Inside, the yeast goes into overdrive in the tropical atmosphere. It consumes the sugars and produces gas, expanding the dough, while the gluten relaxes. The sheet becomes airy and pliable. Upon exiting the proofer, the end counter encounters the docker. This is a rolling drum covered in blunt plastic or metal spikes. It looks like a torture device, but it is essential. The docker punctures the dough sheet with thousands of tiny little holes. Why? Because without these holes, the steam generated during baking would have nowhere to escape. It would form massive bubbles, ballooning the crust up like a pita bread or a pillow. The docking holes pin the top crust to the bottom, ensuring a flat, even surface. Next comes the die cutter. A rolling cylinder with sharp circle molds stamps out the pizza shapes. For a standard 12-inch pizza, the cutter moves with blinding speed. The circular crusts continue down the line. While the excess dough between the circles, the web is lifted away. This scrap dough is not waste. It is immediately recycled back into the mixer to be used in the next batch. Now the crusts face the fire. They enter the par baking oven. This is a massive tunnel oven, often 100 feet long, lined with stone or steel hearths. The temperature inside is a scorching 600 to 800 degrees Fahrenheit. But the pizzas are not here to be fully cooked. They are here to be par baked or partially baked. The goal is to set the structure of the gluten and kill the yeast. If we put sauce and cheese on raw dough and then froze it, the moisture would soak into the dough, creating a soggy, gummy layer called the bone line. Par baking creates a rigid, dry, microscopic barrier on the surface of the crust. The crusts travel through the oven for just 90 to 120 seconds. They emerge pale gold, firm and sterilized. Before any toppings can be added, these hot crusts must be cooled. If you put cold cheese on a 600-degree crust, it would melt immediately and slide off. The crusts enter a spiral cooler, a towering conveyor that spirals upward in ambient air. This brings the temperature down to a manageable 80 degrees Fahrenheit. The crusts are now stable, structural discs of engineering, ready to receive the payload that will turn them into a meal. They are inspected by vision systems that check for roundness, burn marks, and hole density. Any imperfect crust is rejected with a blast of air. The perfect ones march on, a literal army of bread, waiting for the Red River. We leave the bakery zone and enter the high-care assembly area. The air pressure here is positive, pushing air out of the room to prevent dust or bacteria from entering. The temperature drops to a chilly 50 degrees Fahrenheit. This is to preserve the fresh ingredients. The golden par-baked crusts are moving fast, aligned perfectly in rows. Their first destination is the sauce depositor. The tomato sauce is the soul of the pizza. It arrives in 300-gallon totes, a blend of vine-ripened California tomatoes, basil, oregano, garlic, and oil. But the sauce must have a specific viscosity, thickness. If it is too thin, it runs off the edge. If it is too thick, the pump clogs. The factory uses a machine known as the Waterfall applicator. Instead of a nozzle squirting sauce, the machine pumps a continuous wide curtain of red sauce that falls across the entire width of the conveyor belt. The pizzas drive through this waterfall. They are completely coated. But wait. A waterfall covers everything, including the belt and the edges of the crust. Nobody wants sauce on the crust handle. To solve this, the pizzas pass under a border-free roller, or a precise blast of air that wipes the sauce off the outer 1-inch rim. The sauce that falls through the wire mesh belt is collected, filtered, and pumped back up to the waterfall. It is a closed-loop system with zero waste. Next comes the cheese avalanche. In the back of the room, workers are loading 40-pound blocks of mozzarella and provolone into massive industrial shredders. These machines can grate 10,000 pounds of cheese an hour. Freshly shredded cheese is sticky. It wants to clump back together into a ball. To prevent this, the shredder automatically dusts the cheese with a microscopic layer of powdered cellulose or cornstarch. This flow agent keeps every strand separate and free-flowing. The shredded cheese is conveyed to a waterfall depositor similar to the sauce. A curtain of white cheese rains down on the pizzas. Optical sensors scan the coverage. The factory has a strict gold standard for weight. If a pizza is supposed to have 150 grams of cheese, 149 is unacceptable and 151 is a loss of profit. The depositor adjusts in real time. Excess cheese that falls off the sides falls through the belt and is recycled. Then the meat. For a pepperoni pizza, the most popular variety in the world, the process is a blur of motion. The factory uses pepperoni sticks, cured sausages that are 3 feet long. These sticks are loaded into a slicer applicator. This machine is synchronized with the conveyor. As a pizza passes underneath, the blade spins at 1,000 RPM, slicing the pepperoni into perfect coins and shooting them down onto the pizza. The computer targets specific zones to ensure even distribution. No 2 pepperonis should overlap, and every bite should have meat. For supreme pizzas, a tumble depositor is used, raining down frozen crumbles of meat and diced peppers. Now the pizza is assembled. It looks delicious, but it is at room temperature. If we put it in a box now, the sauce would soak into the crust, the cheese would slide off, and bacteria would grow within hours. We need to freeze it, and we need to do it fast. The pizzas enter the most expensive and energy-intensive machine in the plant, the spiral freezer. This unit is a towering, insulated box, often 2 stories high. Inside, a stainless steel conveyor belt winds upwards in a spiral helix, creating a path that is over a mile long within a compact footprint. The environment inside is hostile. Giant fans circulate air chilled with liquid ammonia or nitrogen to a bone-chilling -50 degrees Fahrenheit or -45 degrees Celsius. This is cryogenic or cryo-freezing. The speed of freezing is critical to quality. If you freeze a pizza slowly, like in a home freezer, the water molecules inside the sauce, cheese, and vegetables form large, jagged ice crystals. These crystals act like knives, puncturing the cell walls of the food. When the pizza is thawed and cooked, the cell fluids leak out, creating a soggy, watery mess. Blast freezing does the opposite. It freezes the water so instantly that only microscopic ice crystals form. The cell walls remain intact. This preserves the cellular structure of the peppers, the stretch of the cheese, and the crunch of the crust. The pizzas spend about 20 to 30 minutes in the spiral. They enter as soft, fragile items and exit at the top as rock-hard discs. They are now durable enough to be handled by robots. They slide down a chute into the packaging line. First, they are shrink-wrapped. A sheet of thin plastic film wraps the pizza, and it passes through a heat tunnel. The heat shrinks the plastic tight against the toppings, locking the pepperoni in place so it doesn't fall off during shipping. Then the cartoner. A machine erects a cardboard box, slides the pizza in, and glues the flaps shut with hot melt adhesive. A laser burns the expiration date, batch code, and timestamp on the side. This traceability allows the factory to track every pizza back to the specific batch of flour and cheese used. The final step is safety. The sealed boxes pass through a metal detector and often an X-ray machine. These sensors look for any stray bits of stainless steel, plastic, or stone that might have contaminated the food. If a contaminant is found, a pneumatic arm punches the box off the line into a locked reject bin. The approved boxes are stacked by robotic palletizers. These robots arrange the cases in an interlocking pattern on wooden skids to ensure stability. The pallets are stretch-wrapped and rushed by forklifts to the warehouse freezer, which is kept at -10 degrees Fahrenheit. From there, they will be loaded onto refrigerated trucks and shipped to distribution centers. From a silo of flour and a block of cheese to a frozen disc of culinary engineering, the modern pizza factory is a miracle of logistics and physics. It creates a product that is consistent, safe, and affordable, allowing a consumer to preheat their oven and enjoy a meal that took hundreds of people, millions of dollars of machinery, and a global supply chain. It is mass production at its most delicious.